Well, hello everyone. And welcome back to my shop. Welcome back everyone. And yes, we're going to be messing with this 75 vet again. And yes, we're going to be messing with that Quadrajet carburetor. Specifically, we are going to get to the bottom of this cold start problem I have with it, and we're going to get it fixed. Now, I thought I had it going pretty good from the part 2 of the last episode I had on this, but unfortunately that electric choke just seems to have either deteriorated, either the electrical part or the spring part or whatever. It's just not up to par. I've got some spare parts that I'm going to throw at it, and we're going to see if we can't get something to work on it. And so anyway, stay tuned while we get into the art of the choke on the Rochester Quadrajet carburetor. All right. Now I'm going to do a real quick review. I think I talked about this in the part 2 of that carburetor rebuild, but or it could be part of the clips that hit the scrap floor. Didn't make it. But anyway, I don't think this electric choke is stock to this carburetor, to this engine. I believe in 75, the choke was operated by hot air and not electric. I say that because number one, here is the hot air input to the choke housing right here, okay? And it's capped because there is a minute little vacuum hole in between the housing here into the venturi, so it will draw the air. All right. The number 2, the reason why I don't think that this electric choke came stock on it, it's got a fresh air output of the carburetor. What this is for, its only purpose is to provide filtered clean air to a heating device that would heat the air and then introduce it through this tube into this choke to heat that choke up to open it, okay? That's the only function of that. The manufacturers aren't going to put something on there and then put something like that to plug it if it's not needed. Number 3, the way the electric choke was powered was on a splice that is not factory. Matter of fact, it's spliced to the keyed 12 volt going to the HEI, which is a no-no. You never, all electronic ignitions, HEIs or even aftermarket, you want a clean full 12 volt going to that unit, and you don't want it to be loaded down. You don't want it to have any resistor on it. You want it on its own circuit, and that wasn't on its own circuit. And number 4, I've got a large schematic. I've got another online schematic. I found the schematic, and then I've got a manual. None of those 4 sources show a 12 volt circuit to heat a thermostat. So that's why I think it's not stock. I also don't think that intake manifold is stock either. The reason why I say that is in the I believe in 75, this little hump here would be where is the heat crossover between heads that allows exhaust gas to circulate between the heads. The major purpose of that crossover is, one, to heat up, provide a heat source to heat up for fast warm-up, a plenum under the carburetor, and number 2, to have a port to heat the air to get to that thermostat. You notice that doesn't have a provision. That is a block off plate for the EGR valve, which is a whole nother story there. So this manifold does not have that preheat chamber, and it's also aluminum. It's not cast iron, all right? So this is a L48 engine. I believe that intake manifold is off a later model, maybe 76, maybe 77, L82, higher performance 350 engine or version of the 350. So the L48 being your base engine. So the carburetor, I'm pretty sure, is stock. It could also be, well, no, I'm pretty sure it's stock because it's the numbers say it's either 74 or 75. The part number for it is 7045222, which indicates it's a 74 or 75 Quadrajet carburetor for a Chevrolet engine. So I'm pretty sure that's the 75 carburetor, but that intake manifold I don't believe is. So anyway, somebody has put that electric choke on. Was it a kit, or did they pick a choke out of a grab bag and put it in there? Hard to say. But I'm going to replace it with another one, and we'll go from there and see how it does. You can see the housing here is cracked, and I don't know if there was graduations like this there also. So, but that piece is gone. So you can see there's this tip here on the thermostat. I've made a white mark corresponding where I've got it set now, which is the best I've got it set, which still isn't making me happy. The reason why I'm pointing this out is just in case I have to put it back, I'm going to, at least I'll have a reference mark, okay? So now I'm going to remove this screw, this screw, this screw, and this electrical terminal, and this will easily just come right on out. That's a close-up of the inside workings of your choke. You can see that's where the hot air would enter, right down here at the bottom. And there, you may cannot see it, there's a small hole going into the venturi. But this arm here is connected to the choke shaft up here. All right, and that is, when that spring unwinds, is how it moves the choke up there. All right. Okay, these are a couple carburetors I've had in my stash, and that's where I'm going to be getting the replacement chokes, electric chokes for it. This is a Rochester Quadrajet that came on the 79 250 engine that I had in my old GMC pickup. That was blown. But I never could get the carb to work right because of the electronics built into it. But I'm going to use its choke, all right? Because it's physically the same size as the choke that's in the Quadrajet. And this is a monojet Rochester. One barrel. Now its choke is too small, but physically too small, but it'll give me at least a reference where I can do some measurements. I've also got a Quadrajet that's got a divorce choke, so it's no help, and I've got a Holly with a divorce choke. So anyway, we got these, and this is where we're going to get some spare parts from. All right, I checked online, and I didn't find a real good reference for what I'm looking for. But the only thing I know is to try to read the resistance on these chokes to see what we got. All right. Now this one is physically sized close enough to this other one to work. Okay. All right. This is the one I just pulled off. This is the one I'm gonna put on. This came off. This was also a GM. It says on there somewhere, and it came off a 2-barrel Rochester. All right. But physically it's the same size. Now, what I'm going to do is just read the resistance. All right, this is the one I just pulled off. We'll put positive on the electrical terminal, and it will ground through the case. And what are we looking at? Well, that can't be right. Surely I got to have a bad connection there. No, that's crazy. Let's try to go through some ranges here. Alright. Alright, that's auto. Well, if that's correct, that's reading 317 ohms, and that ain't right. You know that cannot be right. Let's read the other one. Alright, now this is the one I want to put in there. Alright, so we're going to ground him there, and we're going to go here. Alright. Alright, he's reading about 13 ohms, okay? That's a real big difference. I'm talking a tremendously big difference. All right, 12.9 to 13 ohms. Let's go back to this one again. All right, make sure I got a good ground. Pretty much close to the same, 280 ohms. That can't be right. Huh. All right, here's another one that's physically too small. But I'm going to try him in. I'm going to just for reading purposes. Let's see what he reads. I've got him marked 90 ohms. Let's see. And I think the actual battery power on this meter is heating that element, which is changing the resistance. Okay. So it went to open. So that could mean that this is bad. Bad. Now these have thermostats, contacts. Well, maybe I had a bad connection. There we go. Doesn't make any sense why it's changing so much. About 9 ohms. It's close. Basically, what this has done is not given me a good concrete basis for anything other than this reading is more in line to what I'm expecting to see. All right, about 13 ohms. I've got it listed here on it as 12 where I read it before. So, okay. We're putting this one in there. We're going to see what happens. What you want to do? See, this is a spring. It's made of bimetal, 2 different metals. When it heats up, it unwinds like that. Okay? All right. So this hook, you want to get that arm in there, hooked in that right there. All right? You want to be able to freely spin it. Okay, tighten it down to where it at least holds. Okay. Now, what I'm going to do, there's already a mark on that. I'm going to line that tit with that for this particular test. What you want to do, you can see the choke is open. Okay. What you want to do is floor the throttle plate, and what it should do is close the choke. And how you want to set this, the tension on the choke, is where it just closes it. All right, you don't need it to be so tight it slams it and it'll never open or take forever to open. You want it to where it just closes it. So right now, I've got the tit right here lined up with that mark, where the old mark. I'm going to floor the throttle to see if it sets it. You see it set it, okay? And that's pretty good spring tension. What I'm going to do is open the throttle, set that up, all right? Now I'm going to lean it some more. Just about what I would guess is 2 notches. Now I want to see if it'll close it, all right? And it does. So I'm going to lean him some more. All right? I'm right on the middle notch now of that. So let's set him wide open. See, the throttle, this linkage is also connected to the throttle linkage too. The throttle plate, when you throw your throttle maximum, it will open this choke if it's not fully closed. All right, I'm sitting about midway. Now I want to see if it'll close. You see it doesn't. So I know I don't have enough tension. So I'm going to go back 2 notches. All right? Let's see what we get. And he closes it. And I've got pretty good tension. All right. That's where I'm going to set it. Right there. So we're going to lock him down. All right, plug our electric in. All right, so we're sitting about right there. All right. All right, what I'm doing is using my Mighty Vac here, and I'm connected to the pull down. Now what I want to do is test to see I've been having to bend this arm. This is the unloader. When the engine starts, vacuum is applied to this pull down, and it's supposed to crack that choke plate just open, okay, so that it'll idle. And Bubba had this thing bent so much that way that it would open this wide open, you know, basically bypassing the electric choke, and it would always stall, and it was very cold natured. You need partial choke for a cold type engine. So what I'm going to do is pump this up. All right, it's kind of going to be off camera, I guess. Main thing is watch this and watch this. All right, here we go. Now you see where it pulled in, and look how much it's cracked it right there. That's pretty. You want a 1/4 inch around in there somewhere, and that looks very close. So that's where I'm going to leave it. All right. Now it takes it a while to bleed down because this is just a slow acting bleed down. So anyway, I believe that's where I want it. We'll go ahead and disconnect the vacuum to it. Zoom back out, and we'll hook him back up. All right, so I believe that's where where we want to be. All right, so there we go. Now I'm going to open some doors, and we're going to test this dude. Well, all right, I got my ventilation set up. Now this is going to my attack timing light here. That just provides, that's just a good place where I can pick up 12 volt to go to the light. We're hooked up, we're grounded good. We'll put him there. All right, here we go. I've already floored it several times, so it should start. Let's see what happens. Look at that choke. I think I'm going to make it just a hair more richer. I think it opened a little too much. Generally, after you start at one time, you can't do this. But I'm going to do it anyway. So let's do it. So I'm going to go back a notch richer. All right. I'm going to hold my thumb on there so it doesn't move because it is under tension. All right, I'm coming back There. All right, I went about equal to a notch on the scale here on the housing. All right. Keep in mind the housing's busted here, so I believe the scale may have went to there too. Okay. Now we'll try it again. I thought it opened too much. All right. I believe my fast idle's a little on the low side. So I'm going to up him up. The screw adjuster's right here. And opening fast, a lot faster than the other one. But look how wide that choke is now. I may make him richer. I definitely like that it kicks down faster. I still may make it a notch richer, but I can't really do that setting now because everything's heated up. But that choke opened about, I don't know, 5 times faster than the one that was on there. I would still be at fast idle and not able to kick it down. Here you can see it's kicked down. Now the idle, you can see that, it'll pick up once the engine is warmed up to a good operating temperature. It will be about 800 to 850. I haven't messed with the regular warmed up idle speed settings. The only thing I've adjusted at this point is the pull down, the fast idle, and the choke itself. Now one thing that off the bat that's a huge improvement, I did replace the accelerator pump in the carburetor. There's no stumbling now, even when cold. Like I said, there's no stumbling now, even when cold. And that instantaneous. Now the secondary, it's still not warmed up enough to open that secondary. Cam just kicked off. It should do it now. You can see, I believe the cam may be picking up a little bit on the thermostat. It's idling a little higher than I want, but that's all right. It should settle down to around 850. 8 to 850 once it's warmed up, and you can see it doing it. I'm a lot happier with that choke coil, that electric choke, than the old one. A whole lot happier. So it's drivable faster now. That's the only test I need to do. I may make it a little, one more notch richer. And what I'm going to do is I'm going to get rid of these marks now, because I'm going to have a new reference mark. I am not going back to that old coil, that old thermostat. You know, the meter don't lie. And I'm pretty sure that it's not supposed to be, you know, 200 and some ohms. Now, well, I'll be right back. Okay, it may be hard to see those graduation marks there. Okay, maybe like that. You can see right here where my finger's pointing, that's the last of the lean marks there. And if you notice, let's see if we can get it. I'm just a little bit to the left of that lean mark. And what we're going to do is we may go just a hair more before I do that first start, and I got to wait till tomorrow morning. Like I say, this has been an ongoing thing. All right. Okay, I'm back, showing those graduations. The battery went dead. But anyway, before I do the first start in the morning, I'm going to turn that just a little bit more to the left and what that'll do, it puts more spring tension on the choke, which is basically making it a richer setting for the cold start. All right. All right, to set the choke, 2 squirts. I've got it reaching just a notch over the last setting. Let's see what happens. We're at about 1,500 RPM. I think I'm gonna knock it down a little bit. Too much. Anytime you adjust it, it seems like it drops down, then it'll pick back up again. All right, that's okay. Now I'm gonna see if I can kick it down to a slower RPM. Now it's showing about 800. Once it warms up, it'll get to about between 8 and 850. I think we may have hit the magic spot with this different electric choke, adjusting this rod here on the unloader, and adjusting the fast idle speed. You can see it's dropping down. It's adjusting some, but look at the choke. Get that light out of the way. See, the choke really is it's wide open now, which may be still a little too fast, but I want this drivable sooner than what it was on the old choke. That choke still ain't completely open, but this is really, now it's drivable. Now it's slowly dropping down. That's good. I believe we may have found our magic spot. Cool. So, some of the settings I've done, let's get that out of the way. All right. First off, I keep calling this a busted housing. You know, I've got some pictures, and I'm going to link a picture that shows a stock 75 choke setup that uses the hot air divorce choke. Well, it's not really a divorce controlled choke. And that notch is there. So that's actually built into it. And but see, on this electric choke right here, this point, we'll point here, this part right here is the pointer, and it's way past the scale. So I'm going to make a white mark here, and I'm going to call that my winter mark, because I may have to adjust this more come summer, but I think that's good. Also, you notice I've got a white mark here. Now that's a lot of playing. Now Bubba, he bent this way this way. All right, and it would open that choke all the way, and that's because apparently he already troubleshot it, knew that the electric choke was bad or going bad, so he used an unloader to open the choke, and it would stumble and carry on bad. This was a very cold-natured engine. That and going with the new accelerator pump, I don't have any resistance. So anyway, we're going to do some marks here. We got a mark there, a mark here, and that'll be good for future reference. And I believe we're good, at least until I try to start it again tomorrow morning. I'm going to do a quick review on the choke, on automatic choke, and what it does for these engines. Okay, it does more than just set the choke plate right here. Okay, now I'm not going to take it back apart, especially since I've got it operating pretty good. But you've got several linkages connected to the back of this choke, and also the choke is connected to the throttle. If you notice, if you open the throttle wide open, it will open this choke plate also via mechanical linkage, and it's all behind this housing. There's a step cam back here, and it could have 3 or even 4 different steps. Now what those steps are is they increase the idle of the engine when it's cold. In other words, when the choke is set, it'll idle it faster, okay? And it does it via that step cam, which is linked directly to that bimetal coil in here. And as it heats up, it unwinds, it lessens the tension, and it allows everything to move, all right? So this choke closes the choke. It sets a high idle cam and a mid-range idle cam that'll idle it. Once you kick it down off the high idle, it'll be in a middle idle until you kick it down to the low idle, which is generally it's not until this choke is wide open. Also, on this Quadrajet, you see this is the secondary throttle right here. This through cable, through pin here, and this pin hits this lock. What happens is when that choke is closed to partially closed, it locks the secondary throttles to where they will not run. They will not actuate until it is warmed up. That's a factory design. They just, the engineers didn't want you to run a cold engine hard, and which makes there's a lot of reasons for it. But they actually incorporated a mechanical stop that works off the choke to prevent hard running when on a cold engine. So a choke does a whole lot of things besides just controlling the choke plate. At least on these more modern engines they did. So anyway, that's just a real quick review on the choke. This is just kind of an FYI, just a real quick look. This is that Quadrajet right here, which is which has got the later 79 has the electric control, but the ones before that didn't have the electric control, and this wasn't a very bad carburetor. But if you look, the primary side, this being just a 2-barrel, it looks pretty close to being the front half of a Quadrajet. That's something. So anyway, I just thought I'd point that out, that this Quadrajet is basically a Quadrajet with the 2 secondaries cut off. So anyway, well, all right. It's quite possible that I can stick a fork in this Quadrajet now. This last go round, it's ice cold. It started. Other than me adjusting that idle, it seems to be doing like I want. I'll know more once I get this thing down off the jack stands and get it out there on the road, and we'll see what it'll do. Of course, we know before I do it, I gotta crawl back underneath the dadgum thing and change out that rear end grease. You know, it really needs it. And I really need to do it. I just need to motivate myself to get down underneath there. And that's what I'm going to do the next. I should be done with this and stick a fork in it. Although I'm not going to put the air cleaner back on until I do a cold start tomorrow morning. These mornings have been in the 20s. So this should, this final setting, it should be good. I should be good to go on that. And then I'll get back underneath this daggone thing. So anyway. There's so much more I need to do to it anyway. The interior needs a lot of work. Of course, it needs a lot of jingwa too. So, I don't know. I'll see what I can do about repairing plastic and everything, but I don't think there's too much. And of course, the body, well, it needs a paint job, don't it? The body's in good shape. It just needs a paint job, but that's also back burner. We want to get this thing on the road and get it running around. We also want to take it on the Dragon, but that's a whole nother thing. We'll talk about that when the weather warms up. So anyway, thank you all for watching. I really appreciate the views I've been getting lately, and I know they've all been on that right there. Not much on this, but that's fine. That doesn't require the maintenance right now that this is requiring. So this is, this is what I got for new stuff. I've been putting the old stuff out on that, and it seems to be pretty popular. But anyway, it's just running great, cruising, taking care of business, doing my errands, and we want to get this to that condition, and then we can maybe do something about the appearance of that old truck over there. There's not a whole lot I want to do to it. I do want to get the dents knocked out and maybe do a paint job to it. But that'll come. Right now it's just so original, and that patina is so good, and it shines so well. When I put a new coat of that linseed oil on it, we'll go from there. But anyway, we're going to have to do some stuff with this dude and get him ready so we can do some more work on that Chevy, on the truck. So anyway, thank you for watching. Hope everything's going good with you and yours. Everything's going good here. Can't complain. I do complain a little bit just to holler at the moon every now and then. But generally, I just want to take care of the business, and that's what we need to do. So have a good one, and I hope to see you around on the next one. See ya.